Well, welcome back, everyone, and again, thanks for coming. What I'd like to talk about now is another general reason for finding any association between two factors in any study, namely the concept of confounding. So again, this is our cross-sectional study, which we're going to be using as a template to describe this concept of confounding. We had 2,181 smokers, 2,253 non-smokers. 86% of the smokers had existing coronary heart disease. 108 of the non-smokers had existing coronary heart disease. Prevalence ratio is 0.82. Okay. Now let's suppose I gave you some more information about the people in this study. Let's suppose I told you that the 2,181 smokers were essentially younger than the 2,253 non-smokers. So now I'm telling you there are two differences in the two groups I'm comparing. One group is smokers who are mostly young. The other group are non-smokers who are mostly old. And I show you that the prevalence ratio in those two groups is 0.82. But now I'm going to ask you, what's the reason again for that prevalence ratio of 0.02? Is it reflecting somehow the effect of smoking on prevalent cases of coronary heart disease? Or is it reflecting the effect or the association of age on existing coronary heart disease? Or is it reflecting a little bit of both? That one group has two things going for it that the other group doesn't have. One group might be smoking and they're younger. The other group is non-smoking and they're older. And that's the problem of confounding. This is a diagram that tries to describe the scenario I just gave you. We want to know whether there's a relationship between smoking and prevalence of coronary heart disease. This arrow connecting those two factors is what our measure of association is trying to describe. And the question is the number 0.82 that we see in that data set reflecting only that top arrow connecting the relationship between smoking at the 1956 exam and coronary heart disease at the 1956 exam? But in the previous slide, the scenario I just gave you, there's this other factor, age, that has two anticipated relationships. I told you that the smokers in the study were younger than the non-smokers. There's a relationship in the data between whether a person's young or old and whether he's a smoker or a non-smoker. The smokers are younger. In general, if we're thinking about risk factors, we anticipate that age might be a risk factor for developing coronary heart disease. Heart disease occurs much more often among older people than among younger people. So this factor age has two expected relationships. It's related to smoking. I told you that in the data set. And I expect it should have a relationship to coronary heart disease. I expect older people to have more prevalent cases of coronary heart disease than younger people because older people develop heart disease more often than younger people. They have higher incidence. Higher incidence tends to lead to higher prevalence. Well, this diagram says there are two mechanisms by which could explain the relationship we see between smoking and existing coronary heart disease. The top pathway, that direct relationship, that smoking itself might increase the risk of heart disease, might increase the duration of heart disease. For one reason or another, smoking itself affects heart disease. But there's another possible reason for the association that's described as a backdoor pathway. The smokers are older. Older age brings with it higher risk of coronary heart disease, and that's the reason that we're seeing the association we saw in our data set, the prevalence ratio of 0.82. So what confounding as a concept means is we have a lack, let's call it exchangeability. And that's a term we'll talk more about in the future when we talk specifically about confounding. What I'm talking about here is that the non-smokers and the smokers are not comparable. The non-smokers are different from the smokers, not only with respect to smoking status, but also with respect to age. Therefore, the events, the amount of existing coronary heart disease that I see among the non-smokers doesn't predict what I expect to see among the smokers, because the non-smokers are not exchangeable with the smokers in terms of having the same other risk factors that the smokers have. They have a different risk factors. They have a different age distribution. So smoking means the two groups I'm comparing, my smokers and my non-smokers, are not comparable. You can't say that the events that I see among the non-smokers describes what would have happened among the smokers had they never smoked, because the smokers are younger than the non-smokers. That's the lack of exchangeability. In terms of that picture, it means there's this backdoor pathway, this other mechanism to explain, this other reason why we might see an association between smoking and heart disease that has nothing to do with the effect of smoking. It's entirely perhaps due to the fact that the smokers are younger, and younger age brings less risk, smaller risk of developing heart disease. And the problem with confounding, when we have it in a study, is we have to separate the effect of smoking itself on our outcome from the effect of the confounder, in this case, age, on the outcome. But this existence of this backdoor pathway leads to a working definition that you commonly see in epidemiology to describe what a confounder is. A confounder is another factor, like age, that has three main properties. First of all, it has to be related to the exposure. I told you that the smokers were younger than the non-smokers. So that's the first thing a smoking has to do. It has to lead to an imbalance in the two groups you're comparing, your smokers to the non-smokers, a lack of exchangeability, a lack of comparability. They're not the same. They have different age distributions. In addition to that, age has to be related to the outcome. Age has to be an independent determinant of disease, meaning it itself, regardless of your smoking status, age has to bring with it some relationship to your outcome. Older age increases the risk of heart disease, whether you're a smoker or a non-smoker. It could be the reason we see more prevalence of heart disease among the non-smokers because they're older. And the last part, which is again implied by that diagram, is that a confounder cannot be part of the causal pathway linking the exposure to the outcome. It's not that smoking causes you to be old, and older age causes you to have more heart disease. Smoking doesn't cause you to be old. If I was looking at the relationship, say, between obesity and the prevalence of coronary heart disease, I might be worried about diabetes as a confounder. Diabetes might be related to obesity in my data set. The obese people might have more diabetes than my non-obese people. We know obesity increases the risk of getting heart disease. It might look like, in that case, that diabetes is satisfying these first two criteria. It's related to the exposure, obesity. It's a risk factor for the outcome, developing coronary heart disease. But the reason it might not be called a confounder is because maybe the reason people are diabetic is because obesity increases risk of diabetes, and that therefore increases your risk of developing heart disease. And if diabetes was nothing more than something on a causal pathway linking obesity to heart disease, controlling for diabetes would indirectly be controlling for obesity itself. So we don't want to control for factors that are part of this causal pathway. Well, we'll talk more about confounding in future studies, and at the end of this course we'll have a series of lectures that are linked to the idea of detecting and controlling for confounding. But at this point in time, I just wanted to give you the idea that confounding is another reason for finding this association between smoking and prevalence of heart disease in our study, and it's a potential reason for an association in any study. Next time we come back, I want to talk about the last of these general reasons for an association being seen in a study. It ties in closely with what Marcello has been talking about. It's the role of statistical chance. So when we come back, I'll talk about that. See you then.